Hello there, Mrs. Thompson here, and now we are moving on to a new unit. We'll be talking about reactions and moles. And so our first step is chemical equations. Okay, so we need to know the vocabulary that's going to go with our chemical equations. First is chemical reaction. Now, a reaction is when you take something, react them together, and something new forms. In order for us to consider it to be a reaction, something new has to form. Okay, so you have this example here where sodium and chlorine are going from being sodium and chlorine separately to combining. The reactants are always what you see on the left-hand side of the equation. Okay. And the products are what you see on the right-hand side of the equation. Okay. And so it would look like this. Reactants produce products. That arrow's there to show you that they're changing into products. And so if I were to look at this, I have water being formed by hydrogen and oxygen reacting to form water. Okay, we need to know that a chemical equation is just a way to represent a chemical reaction that's happening. A chemical equation will use formulas, all those formulas you loved learning in the last unit, and symbols to describe the reaction itself and all the products that it produces. Okay, so you have to know these symbols and what they mean. First one is S, which is just for solid, but sometimes it's written with a down arrow to show that something has precipitated. So down arrow means it's dropping down, solids forming. Okay, then you have L for, let's guess it, liquid. Good. G, gas. AQ, if you remember, means dissolved in water, which we call aqueous. Okay. And then the arrow means it produces. Another word you might see for this is yields. Okay, plus sign just is used to separate each reactant and each product, but you'll see when we write them in words, that'll be like added or with. So hydrogen and oxygen, or hydrogen reacts with oxygen to form water. And then you have this arrow, which just means that if I have a reaction that needs heat, I put the little triangle above it to show that this reaction requires heat. And then the last one is a double-headed arrow. It just means that the reaction is reversible. We'll spend a lot of time talking about reversible reactions in the future. For now, just think of it as a normal arrow. Okay, you need to know the parts of an equation. And so here we go. Here's our equation on the right. You need to know coefficients and subscripts. So coefficients are just the numbers in front. If we're looking at this reaction here, I'm going to label it with blue. You might want to do the same. We've got coefficients here, here, and here. They're right in front of the chemical formula, and they show us how much of each reactant or product I have. Okay. Then you have subscripts. Now subscripts are found by figuring out the formula using the name. And so they hang down like this. Okay, and just because aluminum doesn't have a subscript doesn't mean that there aren't any aluminums. It just means that there's an understood one and we don't have to write it. So I could technically say that another subscript exists here. Okay. The last thing you need to know how to do with this, probably not the last thing. Okay, so you also need to know how to find the ratio of each substance. And that's just by looking at the coefficient. So for this particular one, I would look at the 4, the 3, and the 2. And then I just write those down and I put a colon in between. So it'd be 4, colon, 3, colon, 2. So this is a 4 to 3 to 2 ratio. All that means is that it takes 4 aluminum atoms to react with 3 oxygen molecules to produce 2 formula units, which is just another name for salt, formula units of aluminum oxide. Okay, take a look at this reaction and see if you can figure out first the coefficients and the subscripts. Okay, so you can see the coefficients are in red and the subscripts are in blue. Now, do you think you can tell me what the ratio would be? Okay, so I'll tell you, I forgot to write this down. It's a 2 to 1. There's nothing in front of the oxygen, but it's understood that it's a 1. So 2 to 1 to 2 ratio. Okay, so why do these equations have coefficients? Well, we have to learn how to balance equations, and that's to show the law of conservation of mass. And so what the law of conservation of mass says is that all of the mass that I have in the beginning of the reaction is supposed to be there at the end of the reaction. All that happens to the atoms themselves is they just rearrange and they form something new, but all those atoms are still there. And so, see this example with sulfur and iron. If I measure the mass of sulfur and iron separately, okay, make them react together, if I take 32 grams of sulfur, 56 grams of iron, that even though I've changed it into something new, it still should yield 88 grams of product. It should have all of those grams that were on the left on the right. Okay, and so how do we show this by balancing? Well, balancing shows the number of atoms on each side. And so the number of each atom on the reactant side is supposed to equal the same number of atoms on the product side. And so if you take a look at this example, on the left side of the reaction, I have 1 carbon. And on the right, I have 1. Okay. On the left side, I have 4 hydrogens. And we can figure out that this has 4 hydrogens by taking the coefficient times the subscript. We'll learn how to do that soon. And so that's 4 hydrogens. Also, oxygen, 2 times 2 gives me 4 oxygens. Over here, I have oxygen a couple of times. I have it right here, 2 of them, and here, 2 times 1, which is 2, which adds up to 4. And so we'll learn how to do that while we are balancing equations. But you need to know that the number of atoms on the reactant side equal the number of atoms on the product side. Okay. So when we balance these equations, what we're doing is we're making sure that we're proving that the law of conservation of mass is obeyed. All right, last part of this, we're going to identify the reactants, what phase they're in, and then identify the products and what phase they're in, and then find the ratio for that reaction. Okay, so we're just going to take this reaction and break it apart into the information here. All right, so the first one, Na, which is sodium. Okay, so I split it from its 2 and its parentheses S. So I just want to know what is that reactant. Okay, and its phase is solid. This would be one of my reactants. Remember that the plus sign separates each one of the reactants. So this separates this from this. Okay. And then I have water as my second reactant. And L, remember, stands for liquid. Okay. And then we'll go to the product side. We have, on the product side, I know it's the product side because there is an arrow. Okay. We have sodium hydroxide there, so NaOH. And its phase is AQ, so aqueous. Then I have hydrogen, and its phase is gas. Okay, hopefully not too hard there. Remember one thing, that the plus signs separate each one of the reactants or products, and that the arrow separates the reactant from the products. Okay, so the ratio in this, remember the ratio just comes from the coefficients. That's 2, right there, the coefficients. A 2 to 2 to 2 to 1. Notice since there isn't anything in front of the hydrogen, that's an understood one. Okay, hope that was easy enough. I'll see you on